So again, cribbing from Chris. Here's at least a somewhat shortened URL for the presentation. The Wholetail project, we like text-dense slides, so there's some heavy text in here, so you might, those who want to follow along. So introductory slides. My name is Craig Willis. I'm a senior research programmer at the National Center for Supercomputing Applications at the University of Illinois at Urbana-Champaign. I work on the Wholetail project. Wholetail itself has many, many participants. This is I'll go into the details, but a National Science Foundation funded data infrastructure building block project with a kind of 5-institution collaboration. And the slide deck I'm going to present, we just fortunately had our NSF review in April, so some of this material was developed for that review, and then I've added some of my own bits to it, but I'll be presenting a lot of things from that others have developed, just for warning. So, Wholetail UW eScience if you want to follow along. So what is Wholetail? Just curious, how many of you have actually heard of Wholetail prior to this workshop? Yeah, small handful. So National Science Foundation funded Data Infrastructure Building Blocks Project, DIBS project. So this is funded not as research, but as infrastructure construction, building a web-based open source platform for reproducible research for the creation, publication, execution of what we call tails, which I'll talk a little bit about later, but really just comes down to binders or capsules, the idea of packaging data code and the details of the compute environment all in one. It's driven by community engagement, so we don't have specific science cases, which are traditional in these kinds of big infrastructure projects. We have working groups. So we've got working groups, internships, fellowships, collaborations that are kind of our mandate for the development of the system. In addition to building infrastructure, we're also looking at enhancing education and training. So this is developing, actually in collaboration with CodeOcean and the Odum Institute, some open carpentry materials for packaging research for computational reproducibility. All right, so what's in a name? This is just may not be clear to you why Wholetail, and I wasn't a part of the project at the beginning. I was not involved in proposals. This is kind of their clever little, they call it a double entendre, but so the tail as the narrative, the story of science, and tail as capturing the whole tail, long tail, short tail, and kind of indicating that we do have a focus to some extent on small scale, long tail research. So the collaboration, as I mentioned, has 5 institutions: Illinois, UT Austin, which is TAC, the Texas Advanced Computing Center, University of Chicago, which bridges us with Globus, if you're familiar with Globus's technology, UC Santa Barbara, this is NC's, and also DataONE, which is if you're not familiar, DataONE's a big network of research data repositories, and Notre Dame, the Center for Research Computing there, and they do a fair amount of the UI development. And the PI team here is split, not split, but you have the kind of technical infrastructure or infrastructure expertise, but also science domains that they touch on. So we've got representation from statistics, astronomy, crop sciences, connecting us with material science community and ecology, environmental sciences, et cetera. Usually Victoria Stodden would give this slide, so I'll do my best. So when we talk about reproducibility and Wholetail, we want to be clear that we're talking strictly about computational reproducibility, not empirical reproducibility or even statistical reproducibility, but really just repeating the computational steps to reproduce these findings. I think this is maybe common to everybody who's presenting today. And why Wholetail? Maybe everybody in the room here would recognize that lots of published discoveries today have data and computational components, and that the software itself even has ideas in it now. The software is increasingly important to have as an artifact of the research process. And there's a mismatch between the traditional dissemination, verification, validation practices, review practices, and what we're producing out of more computationally and data-driven research. So this is kind of our big statement. So we want researchers to be able to easily package and share tails. This is the data code in the compute environment. It might include a narrative or a workflow component. We want to be able to recreate the computational results from those studies to achieve computational reproducibility and setting the default in research to reproducible. So making this kind of an easy thing for folks to do and a natural thing to do. And then because of this, you're empowering users to now verify and extend that. I can take your work, I can tweak settings from it, I can play with it, I can build on it more easily. So I think Wholetail, CodeOcean, Binder, I don't actually know for Stencilia, all emerged around the same time. I think all of these projects kind of popped up around 2015. Different sources, different projects, and there's increasingly a need for this kind. Were you guys kind of same time frame, or? Okay, so there's clearly a need for this kind of reproducible research platform, or perceived need for this platform in the sciences now. And so this is another Victoria Stodden slide. So she says that improved transparency that will come from these platforms will allow researchers to now run more ambitious computational experiments, and that better computational experiment infrastructure will now allow researchers to be more transparent. And so that's kind of considered the context for Wholetail as a project as it's emerged. I just added this actually before this presentation, as nobody had brought it up. So the National Academies has just published their consensus report on reproducibility and replicability in science. And I think in our keynote, we had this tension between stronger research practices. Do we invest in stronger research practices, or do we invest in more infrastructure for improved reproducibility? And I personally am conflicted about this because we spend a lot of time learning new technologies. And I think you mentioned the Excel user might be better at research because they're not focused on learning Docker or deploying Kubernetes clusters. They're more focused on actually doing their research in ways that are maybe more efficient for them. They can focus on keeping up to speed. But in this report, they do talk about improved reproducibility, recognizing the need for better record keeping, source code and version control, the use of workflow management systems, tools for the reproduction of results, and publication reproducibility audits, which I think is maybe a lot where this technology kind of fits in now, as well as the use of archival and open repositories, code hosting and collaboration infrastructure like GitHub, GitLab, and the issuing of digital object identifiers. So I thought this was just kind of a nice reinforcement of why we're all here. So I'm going to go through a few examples of, so I've been on this project for a couple of years now, and I've had to learn a lot about the reproducibility space. And these are things that really struck me as good examples of research communities that are trying to pursue computational reproducibility. So anybody here in political science? All right. So American Journal for Political Science was an early adopter of a verification policy. And so they do third-party verification. Every submitted article, once it's provisionally accepted, goes off to a third-party statistician and a curator that verify the packages and confirm that they can reproduce the results in that published work. So really, really narrowly defined around tables and figures confirming that the values match exactly. So they have hundreds of data and code packages already published to Dataverse. Dataverse, if you're not familiar with it, is this one is Harvard's instance of a platform. It's just an open access repository for research data. It's interesting to note that this review process adds it's 6 hours of manually intensive time of a kind of an expert who's really intensively looking at the quality or the accuracy of the results in the code and the organization that they can run it, et cetera. I'm going to focus on this abbreviated workflow from Odom. So the Odom Institute at the University of North Carolina does this verification process, and it linked to this is a very detailed workflow process. Manuscripts accepted, author submits their package to Dataverse, curator reviews the package, verifier prepares a workstation, installs all of the software and dependencies to reproduce, runs and reviews the outputs. Obviously there are some yeses and nos in here if it fails, but they ultimately send a verification report to an editor. Once it's accepted, the package is published and then the manuscript's published. So I'll go through some more examples, but this is probably one of the most intensive review processes that I've seen for computational reproducibility, for trying to kind of implement what we're talking about here. Similar policy adopted by the ACM transactions on mathematical software. Their RCR policy is optional. And you as a referee who would be assigned to do this work, you'd get some credit. You could publish a report with that manuscript, you get attribution for it. There's incentive there. It still takes time. There's still the need to understand the infrastructure that they're using to run this. This is totally open. You could provide me with SSH access to a Linux machine to rerun your code. You could walk me through a screen share where I see you do it. So there's a lot of different ways that people are implementing this kind of stuff. American Economic Association, any economists? No economists. All right. So they are very much looking at AJPS as a model right now. And a couple of things that's interesting here is they're evaluating this process right now. They have 1,400 published packages that have code and data in it right now via AEA Web. They're looking at pre- and post-publication validations. They're looking at getting people to go back and try and rerun stuff that was published years ago. And I just wanted to highlight on the right is this chart of the types of code that are in these packages, which is Stata and Matlab are the bars that show highest. We're in a discussion about Jupyter and R right now, but as we talk about open platforms for the sciences, we also have to recognize that there are plenty of folks who don't use open source software right now, and it's not a part of their practice. So this is just something that's in the whole tale, in my mind, for a whole tale. Another example, and I think this is the last one in this line. Cornell Institute for Social and Economic Research, CISR, has a service within the university that will go and actually rerun your code for you to do an enhanced proofreading for your data and code. And again, they're creating archival packages. This review is taking 4 to 6 hours for someone on staff at the university to achieve. So that's policy-driven, voluntary, resourced by universities or resourced by other groups. And then we have maybe what I'm assuming the majority of the people in the room might be considering here, which is self-motivated. You're in a domain that wants to do this. You want to do this as your own practice. You're not necessarily, you don't have a publishing requirement to do this kind of work. And these are folks that are more likely to, they're very active, say, GitHub users. They're going to be more intent on learning new techniques, so they're comfortable with, say, picking up Docker along the way. They will do things like try and attribute their stuff, getting DOIs for the data, for the code, et cetera. And this is just a few examples from material science, climate reconstruction, computational chemistry, digital humanities, et cetera. And I put a footnote here. I'm increasingly adopting research compendia as this sort of generic thing to talk about capsules and tails and binders and all of these kind of composite research objects. It's an older term, but I think it's also one that's used maybe in archaeology now as a common term. So these example compendia have a lot of things in common. Open access, open source. They might cite and download externally published data. So you're pulling in data from other sources. I think we saw the LIGO tale that Chris presented where they'd taken data from the LIGO project and put it in a GitHub repository because that's what you have to do. Some of that data may be private or require authentication. The researchers are taking it upon themselves to provide multiple methods for you to be able to run it. So install this locally, run it via Docker, run it in CodeOcean, run it in Wholetail, run it in Binder. They're just trying to reduce the burden of somebody to run their code. Many of these are published to archival repositories. So you work in Git, but ultimately you say, I want to publish to Zenodo or Figshare, or in the case of AJPS, I want to publish to Dataverse. You're publishing to a long-term archival repository to get a DOI for that. You might be separating data from code. And then you're using your digital object identifiers for all three pieces. You get one for the manuscript, sometimes the data and the code separately. So there was a lot of context, but I think I hadn't heard a lot of this presented here, is that we have this kind of tension between the activist individual or communities that are trying to implement these policies versus ones where I'm just a researcher who wants to publish a paper and I'm required to do this. And I don't want to pick up 20 technologies along the way to learn to do that, or I don't have time for this paper. So back to Wholetail. Wholetail, and I wish we hadn't chosen the term tail, but we have, so I'm rolling with it. It's kind of in our marketing literature now. But a tail is really a composite research object. Again, it's got your data, your code, the narrative, the compute environment. It's executable, it's publishable. I'll go in more detail. It's standards-based, it's we'll say nascent standards-based. So what we're working with is the Library of Congress's Bagot standard that's been extended for these kinds of objects. The idea that it's transparent, it's verifiable. One thing about data is data's in by reference or by copy. So I can refer to a data set that's elsewhere, and we get a hard citation, a hard link between those things, but I don't actually have to include that data in my tail during publication. We pull it in when somebody goes to run that environment. So the Wholetail platform, and I'll actually show a video. Hopefully I'll have time. The actual video demonstration at the end of this. So authentication, we use Globus authentication. You authenticate using your institutional identity. You get to access commonly used computational environments. This is RStudio. In our case, it's based on the Rocker community images. I'll get into it. That upper bar with these compute environments is now actually implemented using repo to Docker. So we've adopted and extended the repo to Docker, the binder component, as a piece of Wholetail's infrastructure, and that's not something that was there at the beginning. That's something we changed last year. You can customize your environment using repo to Docker, the repo to Docker conventions. This is maybe a distinction with some of these other services, is you can reference and access externally registered data. So we've got DataONE, Globus, and Dataverse right now are 3 providers that we've implemented where we can pull data from those repositories into the environment at runtime. And then publishing, right now we've got a proof of concept. Our initial kind of reference implementation is publishing to a couple of DataONE network member nodes. So from within Wholetail, you click a publish button, your package ends up in the DataONE network, and you get a DOI. So Wholetail is not the hoster of that DOI. We're not a repository. We're an environment where you create stuff to publish. And I'm going to skip that for right now. And I'm thinking, so I'll go through a brief UI view before a video. So we have a browse interface. This is stuff that's made public in the system right now. You've got a image you can identify your tail with in the system, descriptive information. This will look very similar when you look at CodeOcean up next. You've got the ability to create a tail, and creating a tail when it's empty is really just running a Jupyter instance or an RStudio instance. These are blank environments. And Chris, I think a question came up for Jupyter Hub and Binder, the distinction on whether you have persistent storage or you don't. And that's attention Wholetail's faced. So we have persistent storage for you to work on stuff. So we don't have the ephemeral notion of Binder Hub. And so you can stop and restart your instances, and that will persist over time. But then we also want you to publish an immutable thing in the long run that other people can run, that they don't see any sort of intermediate changes. You can run and interact with these environments now. So this is a Rocker RStudio environment. There's some basic metadata at this point. One thing that's not present here is we have, like, a hard link to the citation for any data sets that you actually cite and bring into the environment. And then the capabilities there, although it hasn't been deployed yet in either DataONE or Dataverse, but we have the ability now for them to add these kind of what we call analyze in Wholetail button that allows you to launch an RStudio or a Jupyter instance from that repository for researchers to just do interactive work on top of data sets that are hosted in those environments. So if you're not, we have a very repository-centric view of the world. We work with research data repositories, and that's kind of a part of our focus. I certainly want to go into the detail of the platform, but I do want to emphasize a couple of things. So we run on Nsf Infrastructure. So this is Jetstream, Chameleon. If you're not familiar with them, this is their version of GCE and AWS, and that's a blessing and a curse. So we're very tied to kind of the Nsf Infrastructure model right now, which is quote unquote free for us, but comes with some maintenance work. We'll put it that way. All right, so I'm going to do a demo, and not a live one because I'm not ambitious. This will be a video, and it's going to walk through it's a synthetic example based on the work here of Josh London. Josh works in fisheries research for NOAA, and they built a tutorial, and we built a tail off of that tutorial material just because it nicely uses data that's in DataONE. And so they have some satellite telemetry data for tracking seal migration patterns that's been published in DataONE. And what I'll show is how you could build his tutorial material and republish that back in the DataONE as a package. And I'm a breathless presenter, it's a breathless video, so I'll try and pause along the way. And I do have a full screen. And so lots of editing for time because this process takes a while and a number of steps. So they've developed an R package that's for kind of modeling and tracking these seal migration patterns with nice visualizations in R. So the first step is so DataONE hasn't deployed this yet, but the capabilities there both for DataONE and Dataverse. So I search for the bearded seal telemetry data set via DataONE's interface. We'll see I think I might expose the data, show you the data here. Each seal is tagged and there's a zip file for their movement data. And we've got this analyze button on the right that allows me to open either in this case an RStudio, it's a Rocker RStudio environment or a Jupyter environment. And it comes in with the name of the data set in this case. I'm just going to give it another name. I'm going to launch that tail. And so what this is going to do is it's going to register that data set. So this is externally hosted DataONE's network. We don't actually pull the data in until somebody accesses it. We just pull metadata about it and expose it. It looks like just files on a file system to you. I get an empty RStudio environment with that satellite telemetry data set mounted. And Oldtail's got some oddities. So you're running in RStudio or Jupyter or any environment. I'm going to go back to that because that went too fast. But we also want you to have a consistent experience across environments. And if I can get this, the Files tab here. So you have a home directory that's mounted across all tails that you're running. That's your private directory. You can put your keys and passwords in that no one else can see, although we don't do HIPAA or anything like that. The external data will be that same. It'll be another way of looking at that mapped in data. And the workspace itself is what you're seeing in the RStudio environment. So we have kind of two interfaces to do the same thing. I can either interactively create or upload files via the whole tail interface, or I could have done it in RStudio or in Jupyter if I wanted to. So this is just the canned code from his tutorial. So again, we see our interface to that same reference data. And now within that workspace, I see, and I'll just note here because Chris has already kind of talked about this, we've got the install.r, which is the repo to Docker convention for R, which I guess I'm covering in the next segment. So this has the packages that would be built into the images. Now, in the binder case, every time you push to Git, you're going to get, the option to build a new image. In our case, you're explicitly rebuilding. So in this case, we're saying, I really want to rebuild that. I've changed some files. We detect changes in the local workspace. We have a much less pleasant view of the Docker logs, which you hope you never have to look at. But this allows you to debug, say, configuration typos, infrastructure errors when it fails to build. And now, I can restart that tail. Hopefully I do that. Now I'm just going to run the environment here. So you can restart with the new image, which now has effectively a Docker image or a quote-unquote virtual machine that has those packages installed, and I can just run their analysis. And this example is partially chosen because it's got some nice interactive visualizations in it, but it is also long-running. So nice crossfade, but this is all our markdown interactive stuff. And sorry, I'm obviously not well scripted. We have very, very basic metadata. What's in this video is actually changed over what's in the latest release. So we actually have the ability to add multiple authors in a nicer way. License selection, we can talk about the role of licenses in reproducible research at some point, and this information all gets pushed to DataONE at publication time. So now you've built your thing in Wholetail. You may want to do something else with it. We give you the option to export it. This will download a zip file, and most of us only care that it's a zip file. It's in a very specific format, which will ideally come up here. So BAGIT is, again, Library of Congress archival format. So the idea is that this BAGIT archive could be pushed to any repository that we don't actually support right now. We've got your workspace. We've got, this is part of the research object community standard. This is a technical metadata standard for describing these sorts of composite research objects that includes a reference to that data set that we cited from DataONE. And then in this case, a very, very basic README that talks about how you can run this locally if you have Docker installed. So prerequisite to run this is going to be you must have a machine with Docker on it. And fortunately, in this case, it'll use a cached image. So it'll go through, it'll use repo to Docker, our extension of repo to Docker. It'll rebuild that image locally. It'll use, in this case, a tool called BDBag to go fetch data. BDBag is just as a researcher, you don't care. As an infrastructure person, you care. It's an open package that allows big data transfer via a variety of different protocols in the Baggett paradigm. And now I get an RStudio instance that looks remarkably like the one that I was running up there with that workspace in place. With the reference data has now been downloaded locally to my machine. And so this would allow me, we don't have a verification step right now, so this would allow me to rerun in kind of a clean environment to confirm that I didn't have anything weird misconfigured on the Wholetail side, or a way to share and distribute this with others. And so ideally it produces the same stuff. So Wholetail, I think we'll see a distinction with CodeOcean. CodeOcean actually hosts your built image with a DOI. Wholetail decided early on that we're working with DataONE. We're going to rely on existing repository infrastructure. So your package gets published to DataONE. DataONE handles long-term archiving. The one problem with that is we don't push the image. We just push effectively the workspace definition. And we don't yet have the feature where you can easily rerun that from DataONE at the moment, but that's in our next release. So you get a DOI from DataONE. This is the equivalent of maybe publishing your binder to Zenodo right now, and only a couple of the DataONE member nodes are targets at this point. And this effectively has the same information that was in that downloaded Baggett file. And the DOI then gets kind of associated with the object and in Wholetail itself. All right, and that was that. So just kind of references to the work we abused for this. So I still have 15?
Yeah, you start, yep.
Okay. If I can find back where there's my demo. I guess I probably had it in present. All right, so go back over some of the key features that we have. So we're in version 0.7, so we consider this. We're still very much under development. For those of you, if you decide to do anything tomorrow, that's just a caveat. So this, in 2018, we made the explicit decision to better align with what had emerged as a very popular platform, Binder, repo to Docker, and we kind of retrofitted Wholetail to work with that, and it solved a number of problems for us, and it also allowed us to contribute our use cases back to Binder, even though we don't contribute the way that we'd like to, because we came from different architectural kind of patterns, but we're trying. So we have Jupyter, we have Jupyter Lab. One of the things, the Karthik's example is there, but this is an open discussion for us, is the Rocker project. If anybody use Rocker images in their work right now, so we have a couple, so it's kind of an amazingly intricately curated set of packages for R that's based on kind of a different lineage of Linux stuff, and you want to use that as your base. So that's what we've been working with the Binder group with, is to find a pattern where we can allow people to just use Rocker and to still have the Binder, the wonderful Binder ability to customize that environment. And I'll talk a little bit more, but Matlab and Stata are important for the communities that we're hoping to serve here, and that's doesn't fit with a lot of kind of the open models because these are licensed software, but we do have the luxury of institutional licensing via Nsf Infrastructure, so Matlab network licenses make it possible for us to now allow people to run Matlab. We're going to increase the data repositories. So right now we've got DataONE and Dataverse Network, which is actually pretty huge. I think there's probably 90 repositories in there. But we want to, I'm still in key features. So that's what we have right now, plus Globus. And Materials Data Facility for Material Science is the one Globus kind of target that's in there right now. reference data is cited, so that's nice. We get an explicit citation. We'd really like when you publish that back out, that increases the citation count on that data set elsewhere. So in the sort of make data count, citation, incentive stuff that we're actually fitting into infrastructure, be able to do that. So we get to publish to a couple of DataONE member nodes right now. This is our reference implementation, but as I'll talk about later, we are planning to do Dataverse as well as Zenodo. We looked at export, so Baggett is a long-term archival format. That exported thing is rerunnable in Wholetail. The Baggett RO standard, when we talk about standards, this kind of idea of describing a composite research object package, there's no real standard there right now. So this is, it's emerging, it's changing, so I should probably quote standard, but we're at least, we've put a stake in the ground for where we want to go with this. So that export capability plus repo to Docker made running locally a no-brainer. You know, it's a shell script that just effectively takes that export format and runs repo to Docker on it. So that was a super easy feature. The one problem is because of our ability to link to external data, say something hosted on Dataverse or Globus or DataONE, is how to bring that in. And that's where this Big Data for Discovery Science tool, BDBag, comes in, because it allows you to run effectively. We automate it, but it's a command line tool that pulls the data in for you. So we started out on the side of trying to address the problem of researchers in all domains, which is very, very problematic. I think we've kind of narrowed our focus. We've prioritized the list to those that are really kind of ready for this technology, and ideally ones that have these sorts of policies and workflows already in the works. So it's not yet in a review workflow yet, but that's one of our next targets, is we'd really like Wholetail to fit into that. Make it easier on the reviewer and make it easier on the researcher to package this stuff. So on the infrastructure side, I think that was a lot of kind of the technical side, but we do have a community engagement side of the project. So we run working groups that are a little bit stale right now just because of our NSF review, but we'll be kicking off soon. We run workshops. We're collaborating on the development of carpentry materials for packaging stuff for reproducible research. We support interns and fellows through the Research Data Alliance. Just to give a sense of our working groups, again, some of these are a little stale right now. Archaeology, environmental sciences, astrophysics and astronomy. The education and training group is actually very active, and that's that carpentry group. Information sciences, material sciences, reproducibility and provenance, reproducibility infrastructure, which has in the past connected the kind of Binder, Dataverse, the ODM group, and social sciences. So this is actually a pitch. If you do have an interest in engaging on these topics, please feel free to reach out to me. We welcome new participants in our working groups to help shape direction. And so these working groups provide guidance on domain-specific requirements. They provide feedback on our new features, may serve as early adopters, and we've tried to be transparent and provide all of the working group outputs on GitHub. And just again highlighting that this EOT working group really, it came out of just meeting with April at another workshop and knowing the folks at ODM and us all being kind of in the same world trying to work on open materials for helping to teach people how to package. And platform agnostic is another requirement in there. So looking ahead, sharing and collaboration as a feature is a weakness in Wholetail right now. It's either public or not. We want to be able to register data from and publish to Zenodo, as I highlighted earlier, publishing both to Dataverse and Zenodo. And through our collaboration with the Texas Advanced Computing Center, we pick up Cyverse and DesignSafe for plant animal genomics and natural hazard civil engineering communities, and we're working to integrate both of them as data sources, and Wholetail is in integration with their kind of publishing infrastructure right now. So these are just big Nsf infrastructure projects if you're not familiar with them. More environments we talked about. So we haven't done it yet. We've proved out that we can run Matlab in these environments very easily on this networked infrastructure, but the idea of a Matlab build pack for repo to Docker is something that's in my mind right now. So installing Matlab packages, and this is the kind of thing you would not want run on GCE, but for somebody who's installing a Binder hub might be a useful add-on. Stata is a little more challenging, just the licensing. The reproducibility, so we're in starting year 4 here, and one of the big things is once you have infrastructure like this, we can now instrument for provenance tracking a little bit better. And we're not inventing things. We'll be bringing tools in that already do some of this work, but to better track executions, to better trace inputs and outputs and sources, to export that in standard formats that can be visualized through networks like DataONE. And I think this is similar to a pattern that's already happened with the Binder project. We've got issues with data locality, so big data that's hosted somewhere where there's infrastructure that if it could just run a whole tail agent, you could run your tail next to the data to provide access to it, or you might have access. You might need special compute resources. You might need to run on an HTC system to run a workflow. So that's the tech collaboration is looking at that. I was asked to kind of at least highlight some of the differences with the other projects. So Wholetail, so it's a NSF-funded collaboration, which has all of the hallmarks of an NSF-funded collaboration, like lots of PIs, direction issues, research programmers trying to implement stuff, and it's just a fact. It's not a vibrant open source community, although we try to adopt open source practices and have us contribute back to stuff. It still runs like a big collaboration. We've got more of a focus on research repository integration, so you'll see if any of you have an interest in this topic that there's a lot of kind of talk around Binder integration with Zenodo or Binder integration with Dataverse that'll eventually come up. This will all happen, and I wish had we all not started at the same time, we would ideally be implementing that. So we are a building block. The idea is that this platform could be run elsewhere, and we envision it like running at TAC, running it next to DataONE, running next to Harvard's Dataverse if needed to provide compute infrastructure, to provide the kind of container infrastructure. I don't know, it's not how it's different, but I just want to highlight that we leverage repo to Docker. That last bullet is that there was an early decision to not make Wholetail Git-centric. So you don't have to use Git, you can. It's not a pleasant experience necessarily for those of you. If you're a real good Git power user, you're gonna have much better luck. You can do stuff in Wholetail with it right now, but there's some, I can go into details if you're interested. It's just not right, it's not perfect. And then we do have the working groups, the internships, the education and training component. I think maybe that's not a difference. We all might have that. And Chris, I'll just confirm, Rocker support and Binder right now is through Karthik's method, right? Okay, so that's something like it's two very different communities that kind of had gone down their own paths and hadn't necessarily bridged yet, but I think there's a whole world of R users who will benefit from the Rocker project's curated images that they just don't know it yet, and they don't want to learn how to write Docker files, and so something that's easier for them to use that builds on that work is something we've realized was kind of a big gap when we moved to the repo to Docker model, is we want to be based on Rocker or allow users that capability, and hopefully that folds back upstream at some point in a usable way. And that's the end.
Great, thanks so much.
All right.
So we can take a couple of questions before a break on hold. Yes.
Yeah.
Is there a specification around that worked out?
No, and I wish there was. I mean, there are specifications in the research data repository community, but the way you integrate with them is you tend to not use those. So, SWORD and other things like that. So, in talking with Jeff Spies from OSF, from the Open Science Framework, they've also written adapters to a lot of repositories, and there's, from a open source infrastructure standpoint, I think there's an opportunity to have a component that can do that can translate these things. And I'll just say, for the tutorial tomorrow, I wanted to take an AJPS data package for people to kind of walk through how to pull that into Wholetail, and I went to go download it from Dataverse, and it's like, I ended up mounting it in Wholetail, zipping it and pulling it down because it was more convenient. So it's like, the repositories don't necessarily have It's not a standard interface to them in that way. DataONE is, in fact, maybe one way to look at that, but they don't have all of them.
Yeah, so about R in particular, as someone who spent a lot of time
I'm
with
sure.
it's a horrible experience, R in general. But I mean particularly like if you're like installing some R package that works on your Mac locally,
Yes.
and then like try to install it on Hotel, you're gonna get like this incomprehensible error message about the applicant packages. Like, what do you think we should do about this?
Oh, I don't know. I think, well, no, I looked, so CodeOcean, the interface CodeOcean is developed. We can only hope we can ever get anything so usable. You guys have good traction in communities. You, I imagine, have good experience in working with people and troubleshooting these sorts of problems. So,
Nightmares, like, I don't want to do it.
no, well, but you want the research. So the idea, I think, is that you get the researcher to work in these sorts of cloud-based environments where it's not local. And this is the provenance discussion. Provenance is a terrible word outside of, like, I don't know, archaeology, and then it's provenance, I think, but then in research data repositories. But if we can take some of their tooling, the technical tooling to inspect an environment, to figure out what's running and produce the requirements files, the apt files, the R files on their behalf. But getting users to create these things, you have to be a very motivated researcher who wants to pin your versions in a requirements.txt file or pin your CRAN date. Not everybody knows to do that. But if you use open, and I think this is one thing is, Wholetail's still nascent. I mean, CodeOcean, you're in the same timeline, but have maybe some earlier adoption. Folks who are more accustomed to just doing their work in the cloud might do their work in the cloud. For smaller scale research, that's reasonable. If you're running Jupyter Hub in your institution somewhere, I can't find was running Jupyter Hub here, maybe you can be better guaranteed at some point that you'll produce something that's easier to run in the binder environments or something like that, as opposed to just doing everything local. But that translation from my laptop, my Windows laptop, my Mac laptop, to after the fact is always going to be an unpleasant experience, I think.
Another question.
All right.
Yeah, I have a quick question.
No. That's good.
The working groups, internships, education, training, can you comment on what sort of scale you're working with there? Is it geographically broad? Have you done a lot of that? Is it just getting started?
So the internships, and they're active right now, I think it's 3 or 4, they've been approved. So the 2019 internships, so we'll do one there's summer internships. These tend to be undergrad students. It's 10-week intensive. They apply and work with one of the mentors. 4 per year. This is our 3rd year. Working groups have been a challenge for Wholetail because there's a lot of effort has to go into coordinating and bringing people together and getting information and taking notes, and I do a lot of that, and I need to be doing more of it right now. So that's that we should be running, like, so the reproducibility, the carpentries group meets 2-3 times a month right now because we're actively developing material. The other ones have more or less kind of fallen off until I set up another meeting. They were intended to be on kind of a monthly or every other month cycle. But people kind of come and go, they join. So if I get an email, I'll send you an invite, or if you know folks are interested. So, but working groups, this is all wholetail.org. It's probably a little bit harder to find. And most of these will just go to a Git repo with notes. And some of them are more active than others. I think maybe by those notes you'd be able to tell. And so do you have an area?
No.
Okay.
Open-ended.
Okay. So there's, the easier one for infrastructure people is the infrastructure working group. And I've really kind of honed in on the social science group because political science and economics are 2 of the groups that seem most active in trying to implement this sort of review process right now. And that's the case I'm really trying to get into the system. Like, how do I simplify the process of a reviewer accessing anonymously or semi-anonymously your environment without it being public to be able to run it? And I see that as a key offering for Wholetail kind of into the publishing cycle. And so social science is one I focused on there recently, but I'm information science, I'm information retrieval, I'm a generalist. I don't, I love all domains somewhat equally.
Like computer view link where you put your whole tail out, but it's private, and then you have a link that someone else can have to that.
So no, we do not, but that's what I want to happen is if it's not V08, it's 09. We'll be piloting, if all goes well, with a journal called In Silico Plants. That's a new one that they want the reproducible research mark, but they want lower effort for the editor and the reviewer than something like AJPS is doing. And we have to figure out what that looks like, but I'm not an editor, so I need collaborators to help me figure it out.
Do you have some journals already that are embedding?
No, I would like to. That's our next speaker. All right, I think I'm over now.
Any other questions for Okay, well, let's thank Greg once more. And so we're scheduled now for afternoon tea for 15 minutes, so straight